Okay, so for those of you that were here for the last talk, Sentinel went through a bit about the current state of Python. What I want to talk about is a bit about how it got that way and how it will continue to evolve into the future. As Ryan said, core Python dev and Python Software Foundation member. We'll get a bit more into what those mean later. So Python's a dynamic language, more ways than one. Dynamically typed, easy to write, but it also changes a lot over time. The Python most of us write today is not the same as what we were writing even 5 years ago. And so the tools we use change. Simple one, if you go back a bit, that was the only way you could run a script. If you wanted to time a snippet of Python, you had to find it in the standard library, invoke it, and then give it the command you wanted to run. These days, almost everyone will just use module invocation and say, run this module as a script, and give it the commands you want. The libraries change. The standard library gets bigger over time. There's a time when all of those, well, those first three all started life as external modules. Decimal was written specifically for inclusion in the standard library according to the decimal standard. And then these two down the bottom, just collections and func tools, just more built-in utilities over time that people can use without having to grab third-party modules. And then syntax itself changes. Once upon a time, on the left there was the only way, was the correct way to open and use a file and make sure it got released promptly. These days, you can use a context manager to do the same thing, and the with statement takes care of cleaning things up at the end for you. Decorators. So used to be, you'd define a function, and then afterwards you'd post-decorate it to say, oh, well, this was actually a class method, or this was actually a property, or this was whatever. These days, you can put the decorator up front. People can see in the function header that, hey, what we end up with is actually a class method, not an ordinary method, that kind of thing. And then one of the biggest changes going from Python 2 to Python 3, the idea that all strings are Unicode. And so you can actually get access to that in Python 2 by doing a from future import Unicode literals. So how do those kind of changes happen? Why do they happen in the first place? And so to look at a bit of the why, I'm going to take a step back a bit and look at what do we mean by Python. And Python's actually a really big ecosystem. So as core developers, we're kind of at the middle of it, but it's a heck of a lot bigger than us. And so the outermost community and the ones who, a lot of them are only just now making the transition from 2.4. So CentOS 5.5 had Python 2.4 in it. They've only just released CentOS 6, which I think is Python 2.6. And so a lot of people use Python for one-off development. IT administrators, lawyers, economists, animators, scientists, engineers. One of the things I've learned from going to PyCon here and PyCon in the US is just the sheer variety of people that are using Python to automate tasks that they need to do their jobs. And that is a massive aspect of the community. One of the things we can sometimes lose sight of as professional Python devs is that not everybody is building a production app for delivery to other people. We need to keep in mind that there are a lot of people just doing their own scripting for their own purposes. They're not trying to distribute things, they just want to get their job done. That said, there's still a lot of people who are actual product developers, that they're building stuff, that they want to create products, they happen to use Python, but the end user doesn't care. Google, Apple, Bitly, so multitude of web companies like Bitly, all the Linux distros, game developers like CCP, the fact that their product is written in Python, their end users don't care. And so for them, it's a matter of just being able to build quality applications for whatever platform they're writing for. But then you get the tool developers, and they're people writing tools targeting software devs. So for them, again, you don't particularly care what tool they're written in or what language they're written in. You just want to be able to build a good product that people want to use. So the Mercurials of the world, BuildBot, A lot of those are tools that are used in core Python development, so they're the ones that came to mind, but I'm sure there are plenty of others. So that's kind of the outermost layer of the Python ecosystem, are people that are using it to do stuff that's not necessarily Python related. And then we go to the people who put a lot of time and effort into enhancing Python for the benefit of the people in that outer circle. And often people cross the boundary and they're writing these tools for their own benefits in their day jobs. One that comes up a lot, particularly in the scientific environment, is people who are taking and bundling Python, combining the core Python environment with IDEs, with additional libraries like NumPy, and so you get tools like SciPy and Sage that are basically designed, so instead of people having to go find all these tools on their own, they can get given them in a prepackaged bundle. And then, of course, there's all the frameworks and libraries that we know and use every day. While some of us get by just on using the standard library on its own, vast majority of us will grab Python plus other things and then use that combination to do our jobs. And it lets us avoid reinventing the wheel all the time. And in support of that, there's an awful lot of Python-specific tools out there. So enhanced interactive interpreters, tools like CPython to help you accelerate specific components, testing tools, the Python packaging index, all the commercial IDEs, basically designed and targeting Python developers and making Python developers' lives easier. And then again, similarly, supporting Python devs, heaps of documentation and support out there. Things like Python Cookbook, many printed books, online guides, training courses, basically all of the resources that people can go to get help with doing their Python development. And then the advocacy and insight groups, those that are out there promoting Python, things like PyCon.au, and basically creating connections between Python developers to make it easier for people to learn, make it easier for people to find out what they're doing. And so all of this is all stuff that its presence affects the way the language evolves. And then finally we get into this innermost section, which is specifically about creating the core Python language and the implementations that people actually run their code on. Now, if people were here for the previous talks, Senthil spent quite a lot of time talking about the alternative implementations that are out there. These are actually interesting. It's actually an evolution in the last few years that these alternate implementations have become far more central to the way the language evolves. It used to be that CPython just set the direction and these would come along and catch up maybe. Whereas these days, far more likely that we'll actually go talk to these guys or these teams as changes are being made and say, hey, can you implement this? Will it be difficult for you guys? And if any one of these implementations came back and said, no, that's a major problem for us, we can't do it, chances are it'd kill a feature. That said, they're generally working with better technology than we are, so it's pretty rare that they're the bottlenecks. But yeah, so basically the beauty of those alternate implementations is there's some places that CPython just won't go. It's not built for it, and so there's been a few attempts at putting a JIT compiler directly into CPython. They've originally with Psycho, more recently with Unladen Swallow. Both eventually ran out of steam. But the PyPy guys, one of the original authors of Psycho, said, this isn't going to work, took a step back, did some foundational research, and as a result, we've got PyPy today, which gives us a much better platform for optimization. Python Software Foundation has a role to play. It's mostly a infrastructure support thing, but it basically provides the foundation to let everything else happen. It's the intellectual property background, the financial background, runs python.org, that kind of thing. But what you're all here to hear about the CPython reference interpreter. And basically what it does is it provides the pivot point for that entire ecosystem to move forward. The idea is that the alternate implementations are basically just implementing whatever features have already been added here. And yeah, they basically, the thing is that changes that are going to happen to Python and eventually ripple out through this whole ecosystem start here. And really, the basic process by which things change is the obvious one. Someone makes a suggestion, the suggestion gets discussed, people get persuaded as to whether it's a good idea or not, people try out implementing it, see if it's actually going to work. If it survives that gauntlet, someone commits it, and then eventually it gets bundled into a release and published on python.org and starts making its way out to the rest of the community. And so where suggestions come from, obviously we come up with our own ideas. A lot of PEPs are written by core developers, but certainly not all of them. And of course we have the ability to just commit stuff directly. Lots of feature requests come in on the bug tracker. The Python ideas mailing list collects a lot of suggestions. And then also we just look at what third-party libraries are out there, and occasionally sometimes they'll reach a point of maturity that will go, look, these are really the best way to do things. Let's either integrate some features or else we'll import libraries wholesale as shown at the beginning. And so that, yeah, so suggestions can come from all sorts of sources. And that's kind of things. So once the suggestions have been made, then the question of whether or not it's a good idea, whether or not it should be incorporated, exactly what kind of form it should take, then becomes the focus. And so that can actually be quite contentious because there's quite a few competing factors to be balanced out in changing the language. And that's kind of why I went through that whole ecosystem to start off with, because anytime we change something, it has a cost. People have to relearn, people have to update documentation, people have to update training materials. Other libraries may be impacted, the other implementations are affected. So even changes that are genuinely positive ones can have a non-zero cost, just in terms of what people do. And so really the first principle is don't screw it up. Python's pretty good as it is. We think there are ways we can make it better, but we want the evidence or the arguments in favor of changes to be clear and compelling. Yes, this is worth it. And this is, people who are new to the game of proposing change, this is often one of the hardest concepts for them to come to grips with. The fact that being a little bit better is not enough because of the cost of pushing change out through that entire, the size of the ecosystem is such that there needs to be a clear benefit to including things. And so when the arguments in favor of a change are not particularly compelling, then by default, whatever's there already tends to win. We do say no a lot, but it's an interesting tension. You compare it to something like C++, where they just recently announced C++ 11, 13 years after the last version back in 1998. And so at that point, Python's 18 to 24 month release cycle doesn't look quite so slow. But And then the ideal that we're kind of aiming for when we do add new features is that we want the obvious way to do things and the correct way to do things to be the same to the maximum extent we can manage it. That was one of the big motivators behind the with statement, that there was a lot of code, a lot of try finally code. The correct way to write it was not always obvious. Synchronization locks was a classic case where lots of people got that wrong. They put the acquire inside the try block when it should be outside. Whereas these days, with a context manager, you just say with lock, and you're done. And basically, yeah, it boils down to the open source ethos of rough consensus and running code. If nobody writes it, it's not going to get implemented. But if, yeah. So move on, since I've got the 5-minute warning. Richard Jones is giving a talk this afternoon on the XenoPython, which is basically a bunch of design principles that really do guide the way we consider changes to the language. So I'll skip over that and recommend it. But yeah, that ecosystem that I went through earlier, that's really the big thing we keep in mind, and that's what a lot of people coming in with suggestions miss, is the impact that our decisions have on that whole community. And so the role of core devs, the big thing is we get to decide when and where to commit changes. We get to decide how much of a discussion is needed. We can commit stuff directly. We can say, oh, well, we need to put this on the tracker and discuss it. It needs to go to Python dev, or it needs a full Python enhancement proposal. And one of the big things that a Python dev we can do as devs is any commit we can say, look, don't think that's a good idea, please revert it, and we'll take it to Python dev and discuss it. And the Guido van Rossum benevolent dictator for life is the language inventor. Occasionally he'll resolve arguments by fiat, but he's actually really reluctant to do that. And that's a good thing. Basically, he has that power if there's some features that wouldn't be in the language if he didn't just make a decision. So things like conditional expressions and the decorator syntax ultimately boiled down to Guido trusting his gut on the syntax being good enough. And yeah, and so that's basically a useful thing to have as to finish off an argument, but ultimately it's not needed all that often. And so ultimately what that lets CPython do is it's a tool that we hack on it because we want to use it. Even though the version that we're using in production may be several versions behind, eventually we'll get to use the ones we're releasing today. It sets the baseline for all the Python implementations to target. The arguments about new features can really be quite acrimonious because the benefits and trade-offs are not always clear, and it can be quite hard to argue the idea without tempers getting heated. But then the other thing is, ideally we want to support anything with a C compiler. PyPy is great if you're on x86. If you want to run on ARM, you're out of luck. CPython, on the other hand, will probably run fine. And the other thing is that the PEP process provides a vehicle for setting standards that affect the whole ecosystem. We don't always get it right, but things like WSGI, while nobody should really be using WSGI ref directly, but it is what lets all the web frameworks talk to most of the web servers. I've got a little bit of time left. So, yes, how people can help make it happen. It's actually very, very interesting to be involved in core Python dev. There's heaps of things that I wouldn't know anywhere near as much about them as I do. So things like Unicode, floating point network protocols, the standard library covers so much, and just following Python dev can be extremely educational from that point of view. And then just the traditional, the good parts of software development, certainly got plenty of that to do. But the sheer size of that ecosystem that I was talking about is, being at the pivot point for that is kind of terrifying. because if we screw up, then lots of other people have to live with the consequences. But it's also really cool. And there'll be a CPython sprint on Monday and Tuesday. I believe the sprint intros are Sunday evening, I think. Check the schedule. I think the sprint intros are Sunday evening. And yeah, that screwed up a bit. But yes, so there's just some stuff there, and the slides are online, and that's some resources for getting started in core development. I meant to add a dev guide link to that, but yep.
Cool. Thanks, Nick. I can certainly vouch for the value of just hanging out on Python Dev, and one of the great things about being there is you get to read all of Nick's well thought out replies to various people's proposals, so I can, yeah, +1 for that idea. Any questions?
I guess just for anyone who's hanging out at the sprints on Monday and Tuesday, how accessible is that to someone who's really completely beginning?
In what sense? We've got a...
Is it going to be scary and too hard?
No, so if you check out the dev guide on python.org, which I don't remember the exact URL off the top of my head, some docs/dev guide, I think. What we suggest to people that are just wanting to get involved is we've got this thing called Dev in a Box, which is a pre-built, sorry, not pre-built, complete checkout of the Mercurial repo with the coverage data for the standard library. And basically we suggest to people grab a module that's not well covered, look at improving the test suite for that module, or else grab one of the existing coverage patches that's on the tracker, check that, yep, it runs, check that it's all good, and then my basic job for the sprints is I'm not planning to work on anything of my own, I'm just there to help people get started.
There's also a lot of bugs that are very low-hanging fruit, that just need an hour or two of someone to look at and go, yeah, that seems reasonable.
Yep. Yeah, reviewing patches on the tracker can also be very helpful.
Anybody else? Oh, I have one too. Do you have a particular pet feature that you're thinking about trying to push through at the moment? Or?
Yes, actually, I just mentored a Google Summer of Code project for a thing called Import Engine, which is basically taking the global state related to the import system and actually putting it on an object where it belongs.
Okay, so the question I've got is one that the Django project gets a slightly different version of, but in the same sort of vein. The Python core library has sort of two extremes when it comes to integrating third-party libraries. On the one hand, we've got how many different argument parsing libraries